Good morning to all of you. In previous sessions, we were discussing properties of Fourier transform. So, where we discussed about linearity property, time shifting, time reversal, convolution theorem, right? Correlation theorem, Wiener-Kirchner theorem. Uh, then we have seen frequency shifting property and the modulation theorem. So today we'll be discussing the property that is the differentiation in the frequency domain. So it is differentiation in the frequency domain. So as we know, the formula for the Fourier transform, that is, it is denoted by x of omega. It is nothing but the Fourier transform of discrete time signal x of n, and it can be given as n is equals to minus infinity to infinity x of n into e to the power minus j omega n. Okay, so that is the formula for Fourier transform. So as per the differentiation in the frequency domain property, so if there is signal discrete time signal x of n with the Fourier transform denoted as x of omega, then the Fourier transform of n into x of n in Fourier domain or frequency domain is simply j multiplied by the uh, differentiation of x of omega with respect to d omega. Okay, so we'll just try to prove this property. So basically we are interested initially in identifying the derivative of x of omega with respect to d omega. But what is x of omega? So as per the Fourier transform formula, so we can replace this x of omega with summation n minus infinity to infinity x of n into e to the power minus j omega n. So that is nothing but derivative of summation n is equals to minus infinity to infinity x of n into e to the power minus j omega n with respect to d omega. Right? So we'll just rewrite down this equation here. So we are identifying the derivative of summation n is equals to minus infinity to infinity x of n into e to the power minus j omega n with respect to omega. Right? So here I can take this n is equals to minus infinity to infinity x of n outside this derivative because the derivative variable is omega here, right? So I can write down this equation as n is equals to minus infinity to infinity, right? X of n into derivative of e to the power minus j omega n with respect to d omega, right? So the derivative of this e to the power minus j omega n is nothing but minus j n multiplied by e to the power minus j omega n, right? So here simply I can write down this derivative. So it will be n is equals to minus infinity to infinity, right? So it is x of n multiplied by, so its derivative will be minus j n, right, e to the power minus j omega n. Okay, so here I can take this minus j outside this summation n is equals to minus infinity to infinity. So in place of this n, I can take n into x of n multiplied by this e to the power minus j omega n. I will keep as it is, right? So this is nothing but what we had taken derivative of x of omega with respect to omega, right? I'll just rewrite this on this equation, that is derivative of x of omega with respect to omega. So we have now minus j, right, summation n is equals to minus infinity to infinity n into x of n into e to the power minus j omega n. Okay, so I'll just multiply both sides with j, right? So if I'm multiplying both sides with j, then I will get j into d derivative of x of omega with respect to omega is equals to, because that j will get cancelled, so here I will have this j square, right? So one and the same thing. Okay, so summation n is equals to minus infinity to infinity n into x of n into e to the power minus j omega n. So j is the imaginary value and its square will be minus 1. So basically the j square is nothing but minus 1, so minus minus will get plus here, so it will be 1 only. Okay, so it will be simply summation n is equals to minus infinity to infinity n into x of n into e to the power minus j omega n, and it is equals to what, j into d derivative of x of omega with respect to omega. Okay, so basically this equation, that is summation n minus infinity to infinity n into x of n into e to the power minus j omega n, is nothing but the Fourier transform of the n into x of n. Okay, so this is nothing but the formula for Fourier transform. Simply in place of x of n, the value is n into x of n. So this is nothing but the what, Fourier transform of n into x of n. Okay, so the Fourier transform of n into x of n is nothing but j into derivative of the Fourier transform of x of n, that is x of omega d omega, right? So this is nothing but the required proof, and this is nothing but the property, that is differentiation in the Fourier or frequency domain, right? So this is how you can prove this property, that is differentiation in the frequency domain. So in next session we'll be discussing the topic, that is the relationship of the Fourier transform and the Z transform. So thank you for joining this session.